Hey guys, today we are the group 2. So for today's video, we're gonna be doing the lab exercise number 6 entitled Interfacing Keypad with Arduino Uno. So what are we waiting for? Let's start! So for the first program, so let's go here, down here to the document. So interfacing the 4x4 keypad with Arduino Uno board. So let's go around here for the procedure part. So we're gonna connect the Arduino Uno R3 compatible board to the 4x4 keypad as indicated here on the table and graphics. So here it shows the 4x4 keypad, the Arduino Uno, and also the pin configurations. So this is where we gonna put the pins on the Arduino board. So let's start coding by opening our Arduino IDE. So we gonna create a new sketch here. Once that we've created a new sketch, so before we start programming or coding, let's add first the keypad library. So go to Tools, Manage Libraries, search for the keypad. So this is the keypad library, and we're gonna install it. Once we install it, we are now ready for coding. Above here, we're gonna put it and we're gonna include the library called keypad. Next, we're gonna add a constant byte for the rows. We're gonna name it rows and set it to 4 since it is a 4x4 keypad. Gonna comment 4 rows. Next, also we're gonna add constant byte for columns. We're gonna call it calls and set it also to 4 columns. So next, we're gonna define the symbols of the buttons of the keypad. We're gonna add the carve function here and name it hexa keys. Inside of it, it has we're gonna call the rows and also the columns. And equals to curly brace, and inside of it is the buttons or the numbers 1 to 9 and the A, B, C, D, and also the asterisk and the hashtag. 1, 2, 3, 4. Oh wait, it's letter A already after the 3. I'm just gonna copy this line and put it on line 7 and line 8, and we're gonna change it to 4, 5, 6, and D. Here is 7, 8, 9, C. And for the last row, D, hashtag, this will be set to 0 and asterisk. Gonna remove the comma. Okay. Next, we're gonna connect the row pin outs of the keyboard. We're gonna connect row pin outs of the keyboard. Byte row pins and call the rows again. And we're gonna set it on the 9, 8, 7, and 6. Since it already have 4 rows, so we're gonna set it on the 4 different pin outs. Also same as the columns. Connect column pin outs of the keypad. Sorry, it's not a keyboard, keypad. I'm just gonna copy this and put it here. And gonna change it to calls. Then also this, the variable name, call pins. And change the pin out to 5, 4, 3, and 2. Okay. Now we're done with the pin outs. Let's proceed to the initializing the instance of class new keypad. And the comment, initialize an instance of class new keypad. Custom keypad equals to keypad make key map. We're gonna assign key mapping here for the keypad and also the assignment to the Arduino board. Make key map and emit hexa keys as shown here on the line number 5. We're gonna call the row pins call pins, the rows, the calls, and that's it. We're gonna go now to the board setup. The only thing that we put inside of it is the serial begin and set it to again to 9600 baud rate. And for the looping, we're gonna add the car custom key. So custom keypad to get the key. And after that, we're gonna add the if statement here. If the custom key at the curly brace and serial, we're gonna add the serial, the print line. Inside of it is the custom key. So that's it for the program number 1. So I'm gonna pass this to Daniela for checking of the code and also the demonstration of the program. So Daniela?
Hello everyone, so welcome back to another Arduino demonstration, and we are at our 6th laboratory exercise, and we have here the activity of interfacing keypad with Arduino Uno board. So without any further ado, let's start. So for our problem number 1, okay, I have it right here. So let us move on to our Tinkercad simulation. So as you can see, I have pre-made my board. That is because I thought this wasn't gonna work because this keypad that I have isn't the same with what I have here on my simulation. But surprisingly it works. So to test out our first problem, oops, not this one. 1, 2. Okay, let me find my Arduino. Okay, this one. Okay, so our note from our groupmate is to include the keypad library. So I already did that, I think. Yep. Alright, I have it here. I have my Arduino board and port selected. So let me just check if it would compile, and it did. So to test if, why is it not connected? Hello? Why is it connected? Okay, so I have it here. We can test out. We can try pushing the buttons for our keypad. So it should display. Okay, so it is displaying. So we have number 1, we have 2, 3, 4. So that's not 4, that is A. Sorry. So this is 4, 5, 6, and then this is B. 7, 8, 9, C. Asterisk 0, and then letter D. So that's it. That's how simple it is for our problem number 1, just to display what the keypad would input in our serial monitor.
Hello everyone! So for program 2, Arduino Jukebox, I will be demonstrating to you on how to manually write this code on Arduino IDE software and also provide an explanation to you, the illustration of schematic diagram for this program that our group created, experimented, and tested on Tinkercad. So first, let me explain first the scenario on program 2. Create and design a musical jukebox, a menu-driven system running on serial monitor screen using a keypad, comprising 6 preschool rhyme songs or any 6 songs of your choice. With the use of switches, the user can select songs to be played by Arduino, provide a running light pattern for each song, and played as accompanied by the song being played. So this is the menu. Twinkle Twinkle Little Star. We will change the other songs here later on when we write our code. Next is we will go ahead on Tinkercad, and I will explain to you the code here, the illustration here. So first, we have the illustration interfacing a keypad, an array of LEDs, a speaker, to create a musical jukebox, and also the keypad, and Arduino itself, and also the USB that is connected to our desktop PC or laptop. So the connections here is to keypad to Arduino. The keypad has rows and columns that connect to specific digital pins on the Arduino Uno. The diagram uses a ribbon cable, likely splitting into individual connections that plug into the Arduino's digital pin headers. Next is the LEDs on breadboard. Each LED is connected to a different digital pin on the Arduino through a breadboard. Here, resistors are placed before each LED to limit the current, ensuring that the LEDs are protected from excessive current that could damage them. So the value here is 1 kilo ohms. This is the typical ohm value for our resistor to prevent excessive current flow. Next is the speaker. The speaker is connected to one of the PWM capable digital pins on the Arduino as specified in the code pin 10. This allows the Arduino to output analog-like signals to control the speaker for playing music tones or music notes. We will be using this tone function and also keypad library on the Arduino software to provide a schematic tone diagram for our keyboard. This is the following code that we will be using for our typical notes, and also we will have this managed library later on to provide this define constants as variables to use this notes. As you can see here, we have this reminder, include keypad.h. But let me first explain this illustration. So our wiring colors, different colors are used for wires to help in identifying connections between the components in the Arduino. So for our demonstration for our hardware, they will not be hard. It is not difficult to them to connect on the H pin on the LED. Next is the power supply. The Arduino Uno is powered likely through a USB connections, which also allows for programming the board from a computer. And lastly, I will explain the functionality. The functionality of this program is to have the system powered and running the uploaded code. Pressing a button on the keypad causes the Arduino to play a corresponding song through the speaker. Each song triggers a specific sequence of LEDs to light up, providing a visual pattern synchronized with the music. This setup is typical for educational and hobby projects where learning about interfacing different components and simple digital electronics is the goal. So for our breadboard, keypad, the speaker, and the Arduino and the USB is our main goal of our components, and also the LEDs, resistor, and the pin wires. So next is our code. In order for include keypad.h library to work, we need to have sketch include libraries, manage libraries, and search for keypad. Once found, click on its entry and the install button will appear. So let's go ahead, open this Arduino IDE, search for sketch, go for include library, manage libraries, and search for keypad. I have installed here the keypad with the latest version 3.1.1. I've already installed it. And the second thing we will do is to have this simple keyboard, public constants, as shown here, to provide the tone function. So I will copy this. Once copied, I will go ahead on Arduino and paste here all. We will have to define this include keypad H. So the keypad is now included here, and also write a comment down here like define musical notes as constants. Next, we will have this integer now. The first song we will play is the Twinkle Twinkle Little Star. So twinkle star, then bracket. Let me just have space. Have some space here to illustrate. We will have this note again. I will copy this note because we will have our recursion here. Also the space. The Twinkle Twinkle Little Star, I have a notepad here on my left side to have a reference for playing the Twinkle Twinkle Little Star. So I will go ahead and write this tone one by one. So note C4, note C4, note G4, note G4, note A4, note A4, and note G4. I'm sorry. Next is note F4, but note F4, note F4, note E4, note E4, note D4, note D4, and note C4. Next, note G4, note G4, note F4, note F4, note E4, note E4, and note D4. Next, note C4, note C4, note G4, note G4, note A4, note A4, and note G4. Next, note F4, note F4, note E4, note E4, note D4, note D4, and note C4. That's it for our twinkle star. Next is the Baba Black Sheep. In Baba Black Sheep. We have note note G4, note F4, note E4, note D4, note G4, note F4, note E4, and note D4. Next is note D4, note E4, note F4, note G4, note G4, note G4, and note G4 again. Next is note F4, note F4, note F4, note F4. My bad, it's F4. Note E4, note E4, note E4, and note E4. Last, note G4, note F4, note E4, note D4, note G4, note F4, note E4, and note D4. We're done with the Baba Black Sheep. Next is London Bridge is falling. In London Bridge. And we will have note G4, note A4. But G4, note A4, note G4, note F4, note E4, note F4, note G4, note D4, note E4, note F4, note E4, note F4, note G4. Next, note G4, note A4, note G4, note G4, note E4, note G4. We're done with the London Bridge. Next, I will change this song to Wheels on the Bus. I have the copy here, the note. Note C4, note F4. Oh my god. Note F4. Note F4, note A4, note C5. Note A4, note F4, note G4, note E4, note C4, note A4, note G4, note G4. F4 I mean. And note C4, note F4, note F4, note A4, note C5 again, note A4, note F4, note G4, note C4, note C4, and note F4. Next, I will also change this song to And Mary Had a Little Lamb. That's it. Note C5, E5, note D5, note C6, note D5, note E5, note E5, and note E5. I'm sorry, it's note D5, E5, 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 D5, C6, D5, E5, and note D5 again, note D5, note D5, note E5, note E5, and note E5, note E5, note D5, note C6, note D5, note E5, note E5, note E5. We have note E5 again, note D5 again, this D5, D5, E5, D5, C6, and note C6. And last, we have the ring and go. I will also change the ring and go to roll both. Okay, we have A4, A4. I'm just checking. No C4, no C4, note C4, note D4, note E4, note E4, note D4, note E4, note F4, note G4, note C5, note C5, note C5, note G4, note G4, note G4, note E4, note E4, note C4, note C4, note C4, note G4, F4. Wait, G4, E4, E4, C4, 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 G4, F4. 1, 2, 3, 4, 5, 1, 2, 3. G4, E4, E4, E4. We have E4 here. We have F4 and note E4. And note D4 and note C4. Semicolon. We'll just check C4, E4, C5, G4, C4, D4. C4, D4, C5, E4, C4, C4. C4, E4, C5, E4, G4, D4, F4, G4, E4, A4, F4, E4, G4, G4, C4, E4. That's right. Next, we will have this define pins for LED. Constant int LED pins, and we will define this as, let's see here, we have A4, A5, A0, A1, A2, and A3. This is for analog pins. Next is, wait, it's bracket. Just bracket here, I'm sorry. Constant int speaker pin equals 10. It's 10. Right? It's 10. And also Keypad setup constant byte rows was 4. We have 4 rows. 1, 2, 3, 4. 4 rows. And also byte columns. 1, 2, 3, 4 as well. 4 columns. We'll have character keys, rows and columns. Calls. Equals. We will have this. We will copy this one. That's right. This, 4 of this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. With input 1, 2, 3, and A. Here 4, 5, 6, and B. 7, 8, 9, C. 7, 8, 9, C. And asterisk 0 hashtag D, and we will end it with semicolon. Also remove this comma, my bad. So let me check first the syntax. That's it. Next, we will have byte call pins columns 5, 4, 3, and 2. We'll have connect to the row pin outs of the keypad. Also have byte row pins, rows. We have 9876. We have 9876 and 543 and 2. This is the rows. The ones here are rows, and this is columns 5, 4, 3, and 2. That's right. 9876 connect to the column pin outs of the keypad. We have keypad, make key map keys. This is a function with an argument row pins, call pins, rows, and columns. Make key map, that's right, keys. Now I'll explain the function to you. I'll explain this function, make my key map. So the function here is to have a key pin configuration and also set up the keypad H for our library here. That to function this sequence, and also have the blink light pattern. It will also set up the loop function and the setup function. So next we will have this. We will have function to play song. We have void play song. We have the void play song here. Wait, let me check the code. It's 4 void play song in song in length in and ed pin for int I equals 0, I is less than length, I plus plus. We have tone, speaker pin, song I, and I plus and 500. We'll have digital write and ed pin I. This is for playing the song if the song is sequenced in the note. The LED pins will triggers the state of high. Digital write LED pins I modulo 6. This is for referencing for 6 songs on the playlist. I also have a delay of 400. Digital write LED pin low state. Also digital write LED pins I modulo 6. Low. Turn off the current LED. and we have the delay of 100 milliseconds. No tone, speaker, pin. Function of this no tone is to have the buzzer, the piezo buzzer, to stop having sounds or audio. So next we have this function to blink LED pattern. We have void blink LED LED pattern and LED LED pin reference here. We also have the for loop for int equals 0. We have the define, we have the value, and we have the incrementation. Digital write, LED pin, we have set up to high, and also have a delay of 100. Okay. Digital write, LED pin, low. We have also the delay of 100. So this is for the blink LED pattern of the LED here. As you can see here, when the song is played, we will have the blink LED pattern. We have the delay of 100 milliseconds or 0.1 second. With the maximum amount of 10. Okay. 10 or 1 second. Next is to have the void setup. Visualize everything. Serial begin, the typical code. For loop again, value, and implementation, pin mode, LED pins, I, and also have the output. We have serial print, print ln, 1, 2, 3, 4, 5, Arduino jukebox. 1, 2, 3, 4. Oh, it's for only Arduino jukebox. Copy everything here. Also have 1, 2, 3, 4, 5, 6 songs to be played. We have 1, we have 2, we have 3, we have 4, 5, and 6. Oh. First song is Twinkle Twinkle Little Star. The second song is second song is the Baba Black Ship. Third song is London Bridge is Falling Down. London Bridge is Falling Down. Fourth song is The Wheels on the Bus. That's correct. Oops. But Wheels on the Bus. Fifth song is Row 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 Your Boat. Row 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 Your Boat. And the sixth song is Mary Had a Little Love. Mary Had a Little Love. Also have this serial print in rest 1 to 6 on the keypad to play the song. That's it for our void setup. We will have a void loop here. I'm sorry, I have misplaced something. We have pin mode speaker for our here speaker pin to provide the song buzzer. This is very important because this device or component will play the song according to what is pressed down here. So We have the voice setup. Okay. This. Also this. Also have the void loop. Void loop has the character key. Everything here is very complex now. Keypad, get key, and we will introduce the if key is pressed to in song index whilst key 1, convert character to song index, and also if song index is greater than or equal to 0 and song index is less than or equal to 5, we'll have ensure song index falls within valid range. Have the if int songs was this one so this one also this one as well. This one wait where's the London Bridge? Wheels on the bus. What? And thus is Mary had a little lamb. It for our song int also have int song lengths size of song size of int size of int to star size of int size of doubled alright doubled size of twinkle star, size of lava black sheep, size of London Bridge, size of wheels on the bus, size of river, size of Mary had a little lamb. I'm sorry, this is for lava black sheep, this is for London Bridge, this is for wheels on the bus, the fifth song and the last song. Start with this and semicolon, play songs, song index, song lengths, song index, LED pins, song index, link, LED pattern, LED pins, song index, comma, delay of 1 second. This is the debounce delay to prevent multiple triggers. So I will first verify the syntax here. Void loop per key, if key is song index, if 1, okay, song index, okay, during this one's within range, okay, and songs, on. Keep this. Okay. Song lengths. Sorry, 3 here and 3 here. Song length, size of twinkle star. Size of M. Size of M. Okay. Also void loop. Okay. This is all that we need. I will explain to you the loop function here. The loop function on the void loop simply checks for constant key presses on the keypad. When a key is pressed, it calculates the corresponding song index, retrieves the song, and its length form arrays place the song and links the LED pattern. So the void setup here is to have the function initialization for serial communication, configures the pins as output, and prints the many options to the serial monitor. So this is all that we need for our program number 2. Here, I am Cedric Villariza, and the code is now finished. I will give this platform for hardware demonstration to Daniela Francine Velasquez. Thank you.
Okay, so for problem number 2, we have our... Okay, so we will be needing our keypad as usual, and then a buzzer right here. I have my buzzer right here. So to connect, I forgot which one is that. It's the positive one. We will be needing wires to connect. See the positive and the negative. Do you see my... There you go. So I will be putting this for the positive, this is for the negative. Connected to the 10th digital pin, so 8, 9, this is 10 and 4 in the ground. I think this will... Oh, thankfully it did. Is it a bother that it isn't working? Okay, so for our board, we will be needing 6 LED lights over our mile. Oh, there you go. We have it here. So 6 reds. So since you've been watching my previous videos, I think you know now that I don't have enough red LEDs. So we will be doing an alternate. So let's try using blue, red, yellow, and another blue. Okay, just return this to the back. Okay, so red first. This is red, yellow, blue, and then one set again, red, and blue. There you go. So as you know, when we have LEDs, we should be pairing them up with resistors. So resistors that I've been using ever since. Now they're here. We're needing 6 to connect to the ground. Oops. And then this and this. This last two. So this here. And one more. Okay. Wires for connecting the pin. So pin is connected to a 5-4. The next would be connected to this connected to 2 more. Okay, so the third from the last is connected to on this side. Second to the last is okay, so last is here. Just in between all of the wires that we have already put. Oops. To fit. Okay. I think that worked. For our power, we can 5 volts to here. We put ground volts. And of course, for our ground. Okay, I have power now. Let's see. So this is for our problem number 2. Oh, where is it? Maybe I didn't include the library here. I forgot. Let's try again. So, compiling our sketch. I'm sorry, it's having too much errors. Okay, it's done. What do I do now? Oh, I think this is a... Let's try to simulate this, just so I know. Okay. That's too loud. Okay, so... Oh no, it's not doing any sounds. I'll do it, right? Oh, I think... Oh, there you go. So as you can see, I've made a mistake putting it in the wrong input pin. So I will be doing it again. Okay. Is there another? Oh. Oh, I forgot to put. Okay, let me try again because there are missing lights that are supposed to be there when playing our songs. There you go. So that's it for our problem number 2.
Welcome to program number 3, the hexadecimal calculator. In this project, we embark on an exciting journey to create and design a hexadecimal calculator using an Arduino and a 4x4 matrix keypad. This calculator isn't your typical one. It works with hexadecimal numbers and can perform essential mathematical operations such as addition, subtraction, multiplication, and division. Our goal is to make the input of mathematical expression via a keypad and then display both the expression and its evaluated result on the serial monitor. Let's dive into the components, code, and magic behind this fascinating calculator. So the code starts by including the necessary header file for the keypad. Let's type #include and then keypad.h, and then we define the number of rows and columns for the keypad and create a 2D array to map the keys to their respective characters. So let's type const byte and rows is equal to 4 for rows. Then next, const byte and then calls is equal to 4 also. That is for 4 columns. The next is for the characters. Let's type char and keys and then a bracket, then rows, then a bracket, and then calls is equal to braces, and then enter, and then next let's put the braces again, then let's type 1, 2, 3, and plus for the first row, and then let's type the braces again for the second row, and the characters are 4, 5, 6, and then subtraction character. And for the third row, the characters are 7, 8, 9, and multiplication character. And then for the last row, C, 0, equals, and division symbol. Then let's put a semicolon on the last braces. Next, the pins connected to the rows and columns of the keypad are defined in arrays. So let's type byte row pins, a bracket, then inside the bracket is rows, and equals the characters which are 9, 8, 7, and 6. This will connect to the row pinouts of the keypad. Then next, let's type byte call pins and then a bracket, and open and close parentheses, a bracket rather, and then let's type calls is equal to, let's type braces, then inside that characters 5, 4, 3, and 2. This will connect to the column pinouts of the keypad. And then we create a keypad object using the make keymap function. So let's type keypad with a capital K. Next is keypad again with a small letter K is equal to keypad, open and close parenthesis, make key map, and then open and close parenthesis again. Inside that is keys. And then next, row pins, call pins, rows and calls. Next, a string variable expression is initialized to store the user input. So let's type string expression is equal to, then in the setup function, the serial communication is initialized. So in void setup, let's type serial.pin and 9600 for the baud rate. For the loop function, it will continuously checks for the key process and processes the input. So let's type inside the void loop, let's type char key is equal to keypad dot get key open and close parenthesis. And for the next line, we will create an if and else statement. So if open and close parenthesis key and then braces and enter. So if open and close parenthesis key double equals single quotation mark and then equals close parenthesis and then a braces, the single quotation mark with equals key to calculate the result. So next line is long result is equal to evaluate hex expression, open and close parenthesis expression. Then for the next line, serial.print open and close parenthesis expression plus double quotation mark equals, it will print the expression and that equals result. Then for the next line, string hex result is equal to string open and close parenthesis result and then hex. This will convert integer result to a hexadecimal string. And next, convert the string to uppercase. Let's type hex result dot to uppercase, then open and close parenthesis. And next, to print the uppercase hexadecimal result, first let's type serial.print ln open and close parenthesis hex result. Then for reset expression after displaying result, let's type expression is equal to double quotation mark. Then for the else if statement, let's type else if open and close parenthesis key double equals then single quotation mark and C. So the C is the key to clear the expression. Then next line, expression is equal to double quotation mark. Then next line, for clearing the buffer, let's type serial.print ln and then open and close parenthesis double quotation mark and then clear. And for the else statement, let's type else and then open and close parenthesis braces rather, let's type expression plus equals key. This will append other keys to the expression. Then to display the current key pressed, let's type serial.print open and close parenthesis key. Next, The evaluate hex expression function evaluates the hexadecimal expression. So let's type long evaluate hex expression, open and close parenthesis. Inside it is string expr, short term for expression, and then braces, and enter. And let's type int op index is equal to -1. And then char op is equal to 0. So this line is for operator. Next, we will find the operator and its index. So let's type if open and close parenthesis expression dot index of open and close parenthesis single apostrophe, inside it is plus, and then outside the open and close parenthesis is exclamation point is equal to -1. Then outside the open and close parenthesis is op equals single quotation mark, and then plus, then comma, op index is equal to expression that index of open and close parenthesis, then single quotation mark, then plus. Then we will have an else statement, which are type else if expression that index of open and close parenthesis, single quotation mark, and inside it's minus, and then an exclamation point is equal to -1. Then outside it is op equals to single quotation mark minus, then the comma, op index is equal to expression that index of open and close parenthesis, single quotation mark minus. Same with the other character, which are multiplication and division. So next line is else if open and close parenthesis expression that index of open and close parenthesis, single quotation mark, inside its multiplication symbol, and then exclamation point is equal to -1. O is equal to single quotation mark, multiplication symbol, and then op index is equal to expression that index of open and close parenthesis, single quotation mark, and multiplication. Then the last else statement is else if open and close parenthesis expression that index of open and close parenthesis, and then single quotation mark, division character or symbol, and next is exclamation point equals -1, and then O equals single quotation mark, and then division symbol. The next is O index is equal to expression that index of open and close parenthesis, and then single quotation mark, and division operator symbol. Then if, for the next line, if open and close parenthesis, op index double equals -1, then we will return this. Return to 0. It means no operator found. That's why it will return to 0. Next, to split the expression into two hexadecimal number, let's type string first part. and then minus expression that substring, open and close parenthesis, 0, then comma, then next is up index. Then for the next line, string, second part, minus expression that substring, and then open and close parenthesis, of index plus 1. And then let's type long num1 is equal to strpor, open and close parenthesis, first part dot c underscore str, open and close parenthesis, then comma, then null, comma, and then 16. Don't forget the semicolon. And for the number 2, long num2 is equal to strpol, then open and close parenthesis, second part, dot c underscore str, open and close parenthesis, then null, and then 16. And for the result, long result is equal to 0. Then for the cases, let's type switch, open and close parenthesis, O, and then braces. For addition case, which is the case 1, let's type case, single quotation mark, and plus, colon. The next is result is equal to num1 plus num2. And then next line, let's put a break. Then for case 2, let's type case, single quotation mark, minus, and then a colon. The next line is result is equal to num1 minus num2. And then next line, we will put a break 2. And then for case 3, let's type case, in a single quotation mark, multiplication, and then colon. Then next line is result is equal to num1 times num2. And then let's put a break. And for case 4, let's type case, then single quotation mark, and then a division operator. And then for the next line, if open and close parenthesis num2, then let's put a exclamation point is equal to 0, and the result is equal to num1 divided by num2. Then an else statement, else serial.println, then the message is error division by 0. Then after that line, let's put a break. And then next line, we will return the result. Let's type return result. Then that's our program number 3.
Okay, so for problem number 3, I guess we will just be disconnecting our breadboard. Let me just do it here. Then the buzzer, as usual. Okay, so I've disconnected my board and I am left with just this. So let us see if this works. I think I forgot to call the keypad again. I did. Okay. So this is program number 3. Oh, that's my bad. Oh, we didn't copy. Okay. Declare the port, import, then compile. It's done upload. It's done uploading. So for this, I think we have to open our serial monitor just to see 4, 5. Okay, so we will be doing mathematical operations. So, oh. Oh, it's cleared. Okay, I cleared it. So 47 minus 59 is... Oh, where is the... Okay. It's cleared. Where is the... Which button is... this one. Okay, so clear 0 and delete this. So let's try again. So 1 plus 2 is equal to 3. Okay. I guess that works now. Okay, so 79 times... I forgot to put something. 72. 77 plus... And there you go. Oh, it's an... Okay, so that's it for our program number 3. Problem number 3. So it does work now, as you can see from my monitor. So
welcome to the last part of our lab exercise 6, program 4, where we will create a security system project using a password-driven piezo buzzer. This project involves using a keypad for password input, controlling LEDs, and a speaker for feedback. Let's head on over to our Arduino IDE and understand how to write the code. First, let's start by including the keypad library, which is essential for interfacing the keypad hardware. Include keypad.h. And in this version of the Arduino IDE, the software automatically identifies the necessary library upon validating the code when uploading it to our Arduino board. Next, let's define the constants and variables. First, the LED pins array. Now this holds the pin numbers connected to the LEDs. The speaker pins, constant speaker pin, it's only one, it's equals to 10. And then let's create another constant for num tries. So const in num tries is equals to 3. Now this is the maximum number of password attempts that a user can do. And then initialize the attempts to 0. So at first, the attempts will be 0. Then after that, let's set up the keypad. We need to define the number of rows and columns, which is for each for a 4x4 keyboard or keypad. Constant by rows is equals to 4. And we do it as well for the columns. Now we also need to create a 2D array for keys. Or keys rows and columns. Let's change it to A. And then 1, 2, 3, A, 4, 5, 6. So it should be here. And then 7, 8, 9, 6. And then it should be 9. And then an asterisk. Let's double check it. 1, 2, 3, A. 456B 7890 #0 #MD. I think that's pretty good. And let's also specify the row and column pins of the keypad on the Arduino board. So for row pins, rows 9876, 9876. And then by call pins, calls 5, 4, 3, and 9. And then let's also do the keypad. This equals the keypad. With the row pins, column pins, rows, and columns. Let's see. I think that's pretty good. And next, let's define the correct password as a string. So const string correct password. Let's use 1, 2, 3, 4. Make it simple. And then now, moving on to the setup function, we need to configure the LED pins using a for loop and the speaker pin as output. And let's also initialize the serial communication. So as we usually do it, for int I is equals to 0, initialize index as 0, and then I is less than. And increment. Then pin mode, LED pins, I set it as output. That's correct. So pin mode, speaker pin, let's also set this as an output. And then let's initialize the serial communication. So we do it using serial begin 9600 or 9600. And again, we use size off so that we don't have to hard code the number of our pins. And now let's move on to our main loop function. First, we have to check if the number of attempts is less than num tries. Over here, so if attempts is less than num tries, if so, we prompt the user to enter the password and read the input from the keypad until the hashtag key right here is pressed to indicate the end of the input. So put that in the wrong position. So while the hashtag key is not pressed, this will print an asterisk for every key press to maintain a privacy, a sort of privacy within the screen. And let's not forget the delay. This also acts as the debounce delay for pressing the keys, which is necessary when making sure that the input is accurate. Oops. Now, after reading the password, we need to check if it matches the correct password. And if it does, we will call another function, which we will name later on. So if entered password is equals to the correct password, let's name it correct password sequence. Bit of a mouthful, but gets the job done. And now, if it doesn't match the correct password, we call the incorrect password sequence and we increment the attempt count to add to num tries. So we do it like this: else incorrect password sequence. Increase attempts. Oops. Like so. Let's also add another else disable the keypad. Okay, let's check. Let's check it again. I think this has to be here. Let's just fix the footprint. See? And that works. Now let's move on to our next function. So let's use the correct sequence. Correct password sequence. So for this function, we iterate through the lead pins, turning each one on and off sequentially, and play a tone of 440. So let's initialize using a for loop. Initialize using 0. 5 is less than. Increment. Oops. And then for the tone, speaker pin, and then 440 as our default tone. Add the delay, and digital right, lead pins, misclicking that, and glue. Then afterwards, let's turn off the tone from the speaker. And that's it. So basically, this will just check for the correct password sequence. And moving on to the next, just copy it and cut. Now we will also use this one with a slight change. So for -1, and if I is equals to 0, we will not increase it but decrease. Let's check it. Okay, so just move this to the front. So in this function, incorrect password sequence, it's basically a similar action but in reverse order, and we use a different tone of 220. It's basically in reverse order, and if you're curious, 220 is lower than 440. This is A3 and this is A4. So that's their notes. And finally, if the maximum number of attempts is reached, we need to disable the keypad by entering an infinite loop. So disable our keypad. Then serial.println. Correct. Now keypad is disabled. While it is true. Now this will make it loop. And that's basically the code for our Arduino project, which showcased how to use a keypad for passwords, provide feedback using LEDs, and as well as a piezo buzzer. Now we have implemented basic security logic with a limit on incorrect attempts, which is similar to most modern smartphones and websites with passwords. Let's now head on over to the hardware and actual demonstration of our project. See you!
Okay, so for our last program, just like before, we have to connect a buzzer and then 6 LED. Okay, so to connect this to the 10th pin, the ground. Okay, sorry. So just the same as before. Okay, the LED lights are connected still to the analog input. So the green here. The purple is this side. This one is the third one is to the first. And then I didn't need this. The next is orange is connected beside the first. This is second to the last. It's connected to beside the previous. Then the last. I'll be having some problems because it doesn't fit anymore. Okay, never mind, it did fit. So for the power, 5 volts, and then the ground. Okay, so let me just go ahead and select the port. Then ito. Okay, so for this one again, I think we will be needing our serial monitor. Okay. So just as before, we have one. Wait, what is the layout of the? I think it's the wrong password. Okay, so the right password is this. Is that correct? I don't think that's right. Oh. So that's the sound for the right password. This one is for the wrong one. Yep, too many attempts. So our keypad is now disabled. So for that to work, so we have to, oh no, I don't think, yeah, we just reset the Arduino board. Then we try again. Enter the wrong password. Sounds like that. Enter the right password. We have this. So that's it for our Arduino demonstration for today. I hope you learned something, and I'll see you in the next one. Bye!